This lesson is about identifying quadratic functions. Our student learning objectives for this lesson: identify quadratic equations numerically, use vertex form to find vertex of a parabola, and use qualities of parabolas to find maximum and minimum. Essential questions: what is the second difference test? What is vertex form? And what are max and mins? Your Common Core standards are below. Okay, so quadratic functions can be identified using a numeric table or a table of values. If we think about back to linear equations, what made them linear or straight was the fact that they had a constant rate of change. So if we had a constant interval between our x's and we found that y also had a constant interval, then we knew that there was a constant change in slope, or the ratio of the change in y over the change in x. Okay, so if we look at the following table, we can see that it's a linear equation because the change in y values, or the first difference, is constant. So the graph is a straight line. So for each one step that y takes, so it goes from -2 to -1 to 0 to 1 to 2, the y values change by +4. So from -2 to 2, 2 to 6, 6 to 10, and 10 to 14. Now, if we think about quadratic functions, linear functions, first of all, had a degree of 1. Quadratic functions have a degree of 2. So if we think about that, then for quadratic functions, since this difference test and looking at these finite differences allows us to find the degree of a polynomial function, then it should be able to tell us whether it's quadratic. So for example, if the first differences are constant, we know it's linear, or it has a degree of 1. However long it takes to find a constant change in the differences, however many times you have to do the test, that's the degree of that polynomial. So since quadratic functions have degree of 2, then if I were to take the differences twice, then I would know that, hey, this is a quadratic function because my second differences are constant. So if we look at this quadratic function right here, the second difference ends up being constant, so I can say that the function that this table defines is a quadratic function. Next, we'll move on to vertex form. The vertex is a key component when graphing quadratic functions. You need to know where to start, or where the axis of symmetry is, or just where the middle of the parabola is. That will also tell us our max value or our minimum value, which we'll get into later this lesson. But vertex form is used to identify the vertex of a quadratic formula. So if we look at standard form, ax squared plus bx plus c, vertex form is similar. That a is the same a, okay, and instead there's an h and a k. H is your x value of your point, of your vertex. K is your y value of your vertex. Now be careful with the signs here. The original form of a vertex form is minus h, okay, and plus k. So if you see a +3, for example, that means your y value is indeed +3. However, if you see a -3 in a vertex form, then your y value of your vertex is indeed -3. But if we go over to h, if we have x minus h, in fact, it's opposite. The h value is positive. However, if I were to see x plus 3 instead of maybe x minus 3, if I saw x plus 3, I would have to know that my h value is negative. So my x value of my vertex would be negative. It would be -3. Now earlier we said parabolas can either open up or down. Each quadratic function will have either a maximum or a minimum value. But first, we have to determine which way the parabola opens. When looking at the standard form, if A, so that first coefficient, the leading coefficient, is positive, if A is positive, then the parabola opens upward. If A, the leading coefficient, is negative, then the parabola opens down. So, if you think about it, when the parabola opens up, that means on both sides, left and right, it is approaching infinity. It's getting higher and higher and higher. So there can't be a maximum value. Then there's a minimum value, and it happens at that vertex. When it opens down, which means both sides are heading down towards negative infinity, then there is a maximum value and no minimum value. That's all I have for you for this lesson. I hope you enjoyed yourself. Hope you learned some things. If you have any questions, feel free to contact me on BBIM by text message or email. Go ahead, try your homework, and be sure to come to live class, and we'll go over some more examples. Thanks.